Hello students, here I am to talk to you about Poisson distributions. So this is 5.6 in our syllabus, and we'll talk about the mean and the variance, noting that we don't need to prove those things. So a Poisson distribution is when we look at a situation that has an average value and discrete values that start at 0 and can take on infinite number of outcomes. So if we think about text messages sent in a day, since most of these seem to be 0, 1, 2, and 3, maybe this data is from like 2004, but if we have 60 people surveyed about how many text messages they sent, so if these are their 60 responses, then this table could keep going with 11 text messages and 0 responses, 12, 0, and keep going on and on. So in my normal method, I could use my formula to find the mean of 2.75. And coming down here, we can formally define our Poisson distribution. So we use it for discrete random variables, take on the values 0 to infinity, and with the one input being the parameter of the mean. So here's our formula to find individual probabilities. It's mean to the power x times e, that's our natural number, to the negative mean over x factorial. We don't need to know where this formula originates from, and we don't need to memorize it. It's here in our formula booklet. They use m for mean instead of mu, but same formula. And we can see from our formula booklet also that the expected value, well, we know that expected value is mean, but for a Poisson distribution, the variance is also the mean. So that implies that our standard deviation is going to be the square root of the mean. So because our input parameter is a mean, that means that we use Poisson distributions when we have probabilities in a certain time interval or space interval, because that's what creates a mean or an average. So we could have phone calls per day, text messages per day, misprints of pages on a book, etc. So we could use these formulas to calculate the individual probabilities, but we can also use our calculator. Like we saw with binomial distribution, we can use PDF and CDF. So I know that my PDF I'm going to use for exact values. So exact. And PDF, I'm going to use, that shouldn't say PDF, that should say CDF. That's cumulative. Remember, we have particular and cumulative. So cumulative is for values that are at most. So it's x less than a certain value. So these are at most values. And of course, if we have at least, we would just do 1 minus to get the at most value. So this is in our distribution area of our calculator. So, sorry, let me get out of here. All right, yes. Okay, I'm quitting. Yes. All right, so in our calculator, we can go into our distributions menu. If I push up, then I see my Poisson PDF and my Poisson CDF.